Thank you. My name is Lytvynenko. I present you my paper on comparison of the efficiency of autoencoder for the solving clustering problems. The main challenge of applying autoencoder to clustering problems indicated in this paper is that clustering results of the highly depend on of quality of extraction of latent representation of the data. Although autoencoder can effectively reduce of the dimensionality of the data and create a latent space suitably for the clustering, there is a risk that the extracted representation might be uninformative or inaccurate of subsequent clustering. Research goal to compare the effectiveness of classical and variational autoencoder in the clustering task. Research objectives. The research objectives present in this work include one, conducting the comparative and analysis of the effectiveness classical autoencoder and variational autoencoder for clustering task, studying the impact of various clustering algorithms such means spectral clustering of latent data representation obtained through autoencoders. Evaluating clustering quality based on several metrics such as the Violeta index, Davis Baldwin index, adjective rank index, material information, and adjective material information. Identifying the advantages and limitations of using classical and variational autoencoder in combination with a different clustering algorithm for various data types and clustering tasks. Formulating recommendations for selective the optimal clustering method based on autoencoders and clustering algorithms depending on the data structure and clustering quality requirements. Problem statement. The formal formulation of the problem statement as follows. Given the data sets is a dimension vector of features. To multiply clustering method based on autoencoders through a set of clustering algorithms where each method can be classical or variant autoencoder. 4. A set of clustering quality metrics is required to determine the most effective combinations of the methods and algorithms for different types of data and algorithms from internal clustering problem. As you can see, we used Iris dataset from the Hedel database for clustering. In this study, we used autoencoder and variant encoder to solve the clustering problem. On this slide, you can see the autoencoder pseudocode intended for solving clustering problems. Autoencoders are used for clustering due their ability to reduce dimension of data and extract key features. The compressed latent data representation are then utilized for standard clustering method, which improved the result. In this slide, you can see that the clustering is happening on the data, specifically on the inner layer data. In this slide, you see the pseudocode variant autoencoder for clustering. The variational autoencoder is used for clustering by creating latent representation of data from the probabilities distributions. This helps to identify hidden structure and groups as specialty for complex or noise data. This variational autoencoder models data as the simplified distributions with improved clustering quality. The main limitations include the need a careful tuning hyperparameter and the dependency on the properties of data, required adaptation of the meta for specific task. You see on this slide the pseudocode variance and code clustering. On this slide, you can see following algorithm that were used to cluster the inner layers data. K means spectral clustering, affinity propagation, and Gaussian mixture model. On this slide, you can see pseudocode of the clustering algorithm K means. On this slide, you see pseudocode of the spectral clustering. On this slide, you can see the pseudocode of the affinity propagation clustering algorithm. On this slide, you see on this slide you can see pseudocode of the Gaussian mixture model. On this the following criteria were used assessed on the quality clustering: silhouette, score, Davis-Baldwin index, adjusted rent index, and metro information. Adjective metro information. On this slide you can see evaluation clustering quality by this index present on the previous slide, autoencoders and table 1, and for variational autoencoder table 2. This study led to follow conclusions. Cluster encoder generally outperforming viral encoders in the clustering task, showing them more stable and high result. CAM means achieved the best performance with classical encoder across all the quality metric, shield score, adjective, rank index, material information, and adjective material information. For variable encoder affinity propagation provided the best result, particularly in terms of the Chevrolet score, indicator good cluster separation. The Gaussian mixture model performed the worst for the autoencoder and variational autoencoder, suggesting low effectiveness for the AIRS dataset. A radical analysis of the Chevrolet score supports the numeral finding, showing the better cluster separation for classical encoder. As theory with CAM means and spectral clustering, variable encoder displayed more variable results ranging from good with affinity propagation to poor with spectral clustering, indicated sensitive to the clustering algorithm. The research confirmed the utility of the encoder for clustering, specifically a small dataset like IRIS by algorithm choose should be data specific. As a result, emphasizes the importance of using various methods to access clustering quality comprehensively. This study provided the basis future exploration and autoencoders in clustering larger and more complex data set.